Now there are many ways to perform a Riemann sum. And remember, what we do with a Riemann sum is we're attempting to estimate the area under a curve. So if we look at this board right here, we're estimating the area under y equals x to the third over the interval from 0 to 1. And the way we're going to estimate that is by a Riemann sum with n equals 4 boxes or 4 rectangles. And the way we start that is we partition the interval into 4 equal pieces. So therefore, the interval from 0 to 1 is partitioned by 0 to 1/4 to 2/4 to 3/4 to 4/4, 4 equal pieces, so that we'll have 4 boxes who have a common width of delta x equal to 1/4. And then what we need to do is to select a c sub I value within each of the subintervals for which we're going to determine the height of each of those boxes. Each of the boxes will have a different height depending on which interval it is and how we've selected our c sub i's in the interval. So there are many, many ways that you can do this. So we're showing you 3 different ways here. One way is by the selection of right endpoints. That is, the c sub i's in each interval is going to be the rightmost endpoint of the subinterval. So therefore, 1/4, 2/4, 3/4, and 4/4 will determine the height of each rectangle. So if we select the right endpoint to be the c sub I for each subinterval, we have right endpoints of 1/4, 2/4, 3/4, and 4/4. And so our estimate, a sub 4, is going to be the common width, 1/4, multiplied by each of the different heights. So we have width times height, width times height, width times height, and width times height for each of the 4 rectangles here. And 1/4, taking the functional value, x to the third, 1/4 to the third is 1/64, 2/4 cubed, 8/64, 3/4 cubed is 27/64, and then 4/4, which of course is just 1, is 64/64, which is just 1. So adding together those common heights times the common width would give you the sum of the areas of all 4 boxes. And we compute that with our calculator. We get 0.390625. And that actually is an estimate of the area. And you see that the boxes all appear to go above the function, so this is definitely an overestimate of the area. Now, it may or may not be a very good estimate. Definitely it is an estimate of the area using the right endpoints. Now, to direct your attention over here, another way we could select our c sub i's in each interval is by using the left endpoints of each of the subintervals. So if we look over here, the left endpoint of each of the subintervals would be 0, 1/4, 2/4, and 3/4. And therefore our picture would look like this. Our rectangles would have their heights determined by the functional value at the left endpoints, in this case 0, 1/4, 2/4, and 3/4. And as before, the common width of all the rectangles is 1/4, and we'll multiply by the sum of the heights. So we give us each height times the common width to give us an estimate of the area under the curve y equals x to the third. So the left endpoints raised to the third would be 0, 1/64, 8/64, and then 27/64. And then on the calculator, that computed will be 0.140625. And notice here that this is actually very much an underestimate of the area because the boxes end up being well under the curve with all that missing space there. So it appears that the right endpoints gave us very much an overestimate. The left endpoints gave us very much an underestimate. Again, it may or may not be a very good estimate, but it is an estimate of the area under the curve. Lastly, a very common way is instead of going to the right endpoints or to the left endpoints, we may figure a better estimate be split the difference and go with the midpoints of each subinterval. So the midpoint, if we're looking at the partition being 0 to 1, 4, 2, 4, 3 fourths, and 4 fourths, the various different midpoints would be 1/8, 3/8, 5/8, and 7/8. And we're going to use those to determine the heights of our intervals. 1/8, 3/8, 5/8, and 7/8. And again, the common width for all the rectangles is 1/4, and multiplied by, as if we factored it out, multiplied by all of the common heights, we have 1/8 to the third, 3/8 to the third, 5/8 to the third, and 7/8 to the third. And then if we add those together and multiply by the 1/4, we get an estimate of 0.2333984375. And it certainly appears that this is a better estimate than left endpoints or right endpoints, because we see each of the rectangles partly is overestimating and also underestimating. And it looks like splitting the difference, that might be a bit of a better estimate. And again, whether it's a good estimate or not a good estimate, it still is an estimate of the area under the curve. So, ways to make the estimates better is perhaps looking at the function to select a correct way of selecting the c sub i's. In this case, it looks like midpoints gave us a better estimate. But as we're going to see in one of the other videos, definitely a way to make an estimate better is to have more boxes than just 4. Maybe have 10 or 100 boxes would definitely be a better estimate of the area under the curve.